So this one, I think we also had in a test. Which of the following situations is a survey least likely to contain bias? Surveying a sample of people leaving a concert, about their favorite musicians, a basketball team, to determine the average height of high school boys, the leaving a grocery store, about their political affiliation, teenagers who are using social networking websites, about their favorite communication methods. So all the other ones seem to have more of a bias than the grocery store for politics, because pretty much everyone has to go grocery shopping. Now, you could argue that certain types of people go to different grocery stores. You know, there are some arguments, but that's the least bias. Sarah has a coin. She does not know if it's a fair coin. She flipped the coin 100 times and obtained 70 heads and 30 tails. She ran a computer simulation of 300 samples of 100 fair coin flips. The output of the proportion of heads, so we're looking for the heads, is shown below. So she got 70 out of 100 were heads, which is 0.7. And we know we want to compare that to the graph, and it's going to be way out here. Maybe not quite that far, maybe like right here. But still, we see that it's definitely not a usual value. So we'll use that to determine which one is right. This simulation, I just want to point out again, is from 100 fair coin flips. So this is what happens when we flip a fair coin. Her coin is fair, her coin is not fair. 70 of the computer's next 100 coin flips will be heads. That's silly, right? The whole idea is randomness. 50 of her next 100 coin flips will be heads. Also something we cannot know. So because this is so far out of what we expect, we're assuming that her coin is not fair. In a recent survey of 500 people, 45% of them reported that they were going to vote for candidate A in an upcoming election. If the survey was reported to have a margin of error of 2%, explain what that means in terms of the actual support for candidate A. So we know finding confidence intervals, we do mean plus or minus 2 standard deviations, but we also know that in place of the 2 standard deviations, that's also equal to the margin of error. So in this case, the mean proportion was 0.45. Okay, that's where that was the reported proportion, and we can do plus or minus 0.02. So actually, you know what? Since I'm going to have to go back to a percent anyway, I'm just going to do this as percents. Probably the best way to report it. So we'll erase 2, that 0, and we'll just do plus or minus 2%. So that means in actuality, 43% to 47% of the people support candidate A. So that's good enough. Really, we're 95% sure that 43 to 47% of the people support candidate A, but that's probably sufficient to have that there. Number 8 is our first probability problem. And we see that two-way table that we saw in a lot of our probability problems. This one says the results of a survey of the student body at Central High School about television viewing preferences are shown below. Are the events a student is female and a student prefers a comedy series independent of each other? So there's a couple different ways we can do this. We're going to show it with conditional probability here. You only have to do one of these. Or with the multiplication rule of independent events. So conditional probability is P of A equals P of A given B. That's one of our rules, and the multiplication rule of independent events says P of A times P of B equals P of A and B. So in this case, I'm going to call the females event A and the comedy series event B just to kind of match them up with our formulas. So the probability a randomly selected person is female, we go all the way over here. So that's 260 out of the 490 total. We know when we do A given B, we're going to just look at the B column. So this is B, so we're just looking at that part. So we're going to use these two numbers for our proportion. This first fraction equals 0.53. This second fraction, and these are approximations, but we're just trying to show that they're equal or not equal. So those two are not equal, so the events are not independent. I only have to justify my answer, and that's enough math work to justify my answer. So if I'm doing the multiplication rule for independent events, P of A we already said was 260 over 490. P of B is, so here's B, 175 over 490. And P of A and B, so where do they intersect? They intersect at the number 80, so that's 80 out of 490. All of these are out of 490 because they're not given probabilities. So if I type them in, I get 0.19 on this side, and we get 0.16. Those are not equal, so once again, not independent. And you would not have to do both of these on the test. Maybe you do both to check, okay? But only one of them is what you need.